name is Luke. I am a web developer at Mozilla. I am based in Tulsa, Oklahoma. And like Mike said, we have a very similar group, Tulsa Web Devs, down there. We also have Techlahoma, which is our statewide thing that I'm very involved with. So I love traveling and seeing other tech groups and meetups and stuff like that. So I was excited to be able to come out here and check out Springfield. I've never stayed here before. I've driven through a lot, but this is going to be really cool. So what I'm going to talk about tonight is Scary JavaScript Tracks You Online. So this is based on a privacy talk that was at 200OK, which is a web developer conference that we did in Tulsa in June. And I have a ton of content in here, so I'm going to go through it really fast. There is some code examples. They are not in depth. They're actually dumbed down versions of the stuff that I found online, because the stuff that I found online is way smarter than me. I didn't understand it, so I rewrote it in something I do understand. So it is easier to fit on slides, but I'll try to get through basically the heavy text stuff. Towards the end, there's like concepts and data about how much of this is going on, and then things that anyone can do if you're just a user or a coder or a developer or whatever. So I'll try to get through as much of this as quickly as possible. If you do want to ask me a question, you can raise your hand, but I might tell you that I'm going to answer it in a second, so just know that. So Jane Krusakova came to 200OK and she talked about this book by Bruce Schneier, which is called Data and Goliath. This is an excellent book. You should probably read it if you're into this stuff. At the same time, I also got a chance to meet Stephen Engelhardt, who is an intern at Mozilla. He's actually getting a PhD in privacy technology at Princeton with their Web Transparency and Accountability project. So he is definitely the expert that I've been relying on for a lot of this stuff. And the part that I'm going to focus in on from this book is the data that is produced as a byproduct of our online activity. So in this case, we're going to talk about especially browser history, cookies, fingerprints for devices, and then sort of how those are used and how much they are used and what the ramifications of all of that is. So we talk about browser history. The first sort of thing that's meant to sort of scare you or wow you is the browser history vulnerabilities. So this one was, I'm drawing a lot of info from this article here. I'll post these slides so you can get that link. There's CSS history sniffing. Does anyone remember this vaguely? There's basically, whenever your browser draws a link, it draws it, if you visited it, it draws it in a different color than if you have not visited it. So there is an API that's actually called getComputedStyle. This is the magic thing here that you can ask a link what color it is in. So if you can style links to be colors that you expect, you can actually just ask, you can draw a bunch of links on a web page and you can ask what color it's in, and you can tell if the user's been to, you know, your favorite porn site or the politician that you hate or whatever. So that was actually fixed in 2010, which is good. But an outstanding problem is that there is a new way to do this using request animation frame. Anyone familiar with request animation frame API? So this is used by graphics developers, game developers to measure basically like frames per second rendering kind of thing. It relies on the fact that a browser goes through this sort of layout and painting loop, and there are different events fired in between every single loop that a browser does to repaint what you're seeing. So the important thing here is that request animation frame gets a high resolution timestamp between the time of the frame before and the frame now. So the way this works is that you actually set up, this is a request animation frame loop, so you're saying every time the browser paints, I want you to call this code, and I want to get the timestamp, and I want to see what the timestamp is from the last time. So this is just how you would measure like frames per second, right? That kind of thing. Now, the extra part of this trick is that you can take a bunch of links with a bunch of URLs, you can draw 50 of them, and if you draw them with a text shadow with a blur radius of 50 pixels, that ends up being something that is actually takes a little bit of time for a computer to do, more time than just rendering a regular link. So if you draw 50 of those, that ends up being enough CPU that it triggers a little blip in the timing between the frames per second. And basically, you can say, okay, if it took more than, in this case, it's just saying if it took more than 50 milliseconds to draw this, then what I know from changing the URL is that it had to change the color of the URL. So you can draw 50 links to a URL that you know the user has never visited, and then you can change the URL of those links to some other URL, and you can measure how long it took the browser to re-render those links. And if it took more than 50 milliseconds, it had to change the color, and then you know they visited it. So this is still an open bug right now in Firefox and in Chrome. And the reason this is an open bug is because these kinds of timing attacks are not deterministic. They're not super reliable. So it's, you've probably visited these sites. It's not, you definitely have, like the old vulnerability was. So another vulnerability is sort of resource access sniffing. So this is essentially very easy. You can draw an image element. You can make the source of it something that's only available to people that have permission, like say if they're signed into Twitter or they're a member of a certain Facebook group or something like that. And then whenever you draw that element, you can essentially just say, on load, do this, on error, do this. And if it gets an error, it's because they're not a member of that group. So you can essentially run through a bunch of resources that are only available to certain people, draw image sources to them, and find out if they're a member of certain groups or not. This one is a cache timing history sniffing. So essentially what you're doing here is you have a bunch of hosts that you want to see if a user has been to. You create a new image, and you say, there's an image on this website that I know is there. And when the image is loaded, I want you to fire this callback, starting with the time that I first sent, that I created the element. And then when I get in here, when it's done loading, I'm going to calculate the time that it took to actually load. And we're going to say if it's less than 50 milliseconds, it was probably in their browser cache. They didn't have to go over the network to get it because they've already been to that site, they've been to that page, they've seen that image, it came from browser cache. So again, 50 milliseconds, this is sort of a rough guess. All of the smart code that I saw online actually calibrates that, and it tries to get rid of some of the variability in that. So the problem with network-based cache timing attacks is that they're network-based and networks are not reliable, right? So there are actually more reliable timing attacks. This was during DEF CON August 1st while I was learning this stuff. This guy published a way to do this with a video element and use video parsing to do this. So essentially what you do, video elements will actually fire a suspend event after they are done loading whatever resource it was from the network, and then they will fire an error event if that thing is not a video. So you can essentially say, you're going to have this get elapsed time. Again, you're basically creating a timing attack. How long did it take to do this? And then what you do, I think it's in the next one. So you have a certain number of hosts for URLs that you want to check, and then you're going to get the elapsed time that it took to actually process, because right now you're not measuring how long it took to load, you're measuring how long it took to process it. And so the big thing here is that if it takes 5 milliseconds, or if it takes less than 5 milliseconds, then it wasn't actually able to load the image, and so the processing failed immediately. If it takes more than 5 milliseconds, it was able to load the image, and the error happened because it was 15 kilobits big, and it took longer than 5 milliseconds to process that and get to the error. So this is essentially a way to do the same thing, but take the network latency out of the equation. HSTS history sniffing. So anyone heard of HSTS strict transport? So this is an HTTP header that you can send to clients that basically says, don't ever come back to the non-HTTPS version of this website for this amount of time. So this is a good security feature. You should implement it. However, there is a vulnerability that was found. Anyone used content security policy? So content security policy is, again, another HTTP header where you can say, in a certain policy, only allow images from this host, only allow style sheets from this host, scripts from this host, and that kind of thing. So you can control a lot of the sort of script that's allowed to execute. This is an example of just setting a content security policy where you say that the images have to be loaded over HTTP, so a non-secure HTTP address. Then what you can do is, once you've served that, again, you start drawing a bunch of new images. And what you're going to do is say, if there is an image error, then calculate the time. And so you're going to, let's say, why is that a math random substring? In any case, what you're going to do is serve this page with a content security policy that says the images have to be loaded over non-secure HTTP. Then you're going to see when they get an error, because they will get an error, is the error taking less than 5 milliseconds to come back. If the error takes less than 5 milliseconds to come back, they've been to that site before and they've picked up an HSTS pen. So if a site is using HSTS penning, the browser will immediately fail that image in this under 5 milliseconds because it's supposed to load over HTTPS. So if it's less than 5 milliseconds, you can basically say, okay, they've been to that site before because they picked up an HSTS pen, right? Yeah?
So you're using content security policy here, which is supposed to prevent stuff like this from being injected into your page. So is this coming from add-ons?
No. So this can actually come from third-party JS and
that you've allowed
to happen.
So if you've tightened your CSP down, this should happen.
Yeah. If you trust all of the people that are sending JavaScript down to your page, but a lot of people just put like script source safe inline or star or whatever. Just make my web page work, please.
Star.
Yeah. Mixed blend mode history phishing. I haven't quite figured this one out yet. It's kind of a weird trick where this is actually a grid of a bunch of these mole images, and by overlaying visited links or overlaying a bunch of links on top of each other, you can actually do binary math and CSS. And if I click that, like if you were to design a game like that, if I click that, it will actually tell you which websites I've been to and which I haven't. So it requires the user to click something, but the CSS makes it super obvious like what they should click. Okay, so that's history vulnerabilities. Let's talk about cookies. So cookies are great. They let you log into sites. When you log in, you get this this set cookie, right? So you're setting a session, so you don't have to keep sending your username and password all the time. That's great. We love that. So first-party cookies are good. That's what enables stuff like logins and shopping carts and things like that. What happens, basically the fundamental and sort of first basis of online tracking is these things, third-party cookies, right? So people are mostly familiar with this, but in case you're not, you go to a site like techcrunch.com, there's a third-party tracker loaded like appnexus.com, there's doubleclick.net, and because TechCrunch is loading their source, those sites are allowed to put cookies on your browser. The cookies are only ever sent back to them. So TechCrunch doesn't know about their cookies, right? And they don't know about TechCrunch's cookies. But this is the basis of online tracking, is that DoubleClick basically sees all of the ads that you view on which websites you're viewing, right? And the way that works is, let's say I went to economist.com, and one of the things that was in the page was this rubiconproject.com, blah, 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 something advertising, and they set a cookie for me. And anytime I go to any other website that includes a rubiconproject.com ad or whatever the script thing is doing, that cookie will be sent each time. And it will have this referrer down here that includes the URL of the page you were on when that request was made. So that's the basis of all basic online tracking with cookies. So this is from 1999, when basically web was new. People just started learning about, there's these things called cookies. They're really scary. They track you online. And so the wisdom then was just clear your cookies, right? And because everybody loves IE dialog boxes, don't you? So that gave rise to super cookies. So I don't know if anyone actually implemented Flash code, but when Flash was a thing, it has, I think this is local shared objects or long-term storage objects or something. But essentially what trackers would do was they would send down a Flash movie, which is why if you go to every website, it still has a little like, do you want to use Flash on this page, even though there's no video or anything. So they're trying to set these long-term storage objects with the same cookie value, so that even if you go and clear your cookies, they will actually have their code read from their Flash object and respawn the cookie, right? So this is actually code that does that in Flash. I did not test it. I hate Flash. I just looked it up. Apparently you can do this with Silverlight isolated storage as well, but you can actually do this with HTML5 local storage too, and it's far easier to do with local storage. It's far harder to block because there are a lot more valid uses of local storage than there are, Flash without video. Another way to set a super cookie that is particularly nefarious is by abusing the e-tag header. So has anyone used e-tags and HTTP caching and stuff like that? So the way HTTP caching works is if you send a request to some server, it can say that the e-tag, this is basically like a hash of what I just sent you. Like this is the version of the thing I just sent you, right? And so if your browser ever goes back and requests that again, it will send a header with the next request that says, well, if your resource doesn't match this, then send me the new one. Otherwise, I've already got it, right? So basically, the browser and the server can work out like, okay, I already have that version of the resource, so I don't need to fetch it over the network again. I'll just use the cached version. That's fine. So Kissmetrics was actually found to be loading this IJS file where they would set a cookie with a tracking identifier right here. And then they would also have send the same identifier in the e-tag for that. So that even if you were to clear your cookies or disable cookies altogether, your browser will forever and always send that same tracking identifier in this other HTTP header. So they're essentially putting your identifier in a super cookie value inside of HTTP cache. And there's no way to get out of this, right? Unless you disable it cache, I guess. So this is some Node.js code that does that. Just trust me, it does it. HPKP, super cookies, complicated. Let's skip that one. So cookie syncing. Cookie syncing is basically, we all kind of know that DoubleClick or somebody has a certain amount of our browsing history, right? And then you've got Facebook has a certain amount of your browsing history, or Twitter, or whoever. They can all see different kinds of your browsing history based on which of the sites that they have put an identifier on. So there's a practice called cookie syncing. And the way this works is, let's say you go back to TechCrunch because you love hearing venture capitalists in San Francisco complain about things. And you get this user ID from some advertiser has set a cookie on you for 1, 2, 3, 4, 5, 6. That may be like AppNexus or whatever. What they will actually do is they will have an HTTP redirect to a partner of theirs. So that would be like the ad exchange, or the buying desk, or the trading desk, or whatever. So in this case, it might be loadome.com or whatever. So what happens is they send, your browser sends a request to a.com with this cookie, and they send a redirect to your browser to go to b.com, who is their partner. And inside of these URL parameters, they're saying to b.com, I am partner ID A, and my identifier for this user is 1, 2, 3, 4, 5. Your browser then sends this request to b.com, and it says partner a.com says that this user is 1, 2, 3, 4, 5. Also, here's the cookie that you already have for this user, so user is XYZ for B, right? So when they've done that, now these partners essentially have all of your tracking identifiers online. They've synced them across each other, right? So no respawn, I guess. So cookie syncing defeats what's called no respawn. So no respawn is basically when trackers started respawning cookies, they got sued and they got in trouble, and so they don't do that anymore, except that if there's one bad partner in a network of partners that do cookie syncing that does respawn, then the cookie syncing effectively defeats even a partner that's trying to be well-behaved, right? So a partner's trying to be well-behaved, but they have a partner that's not being well-behaved. What happens is, this partner has your user ID 1, 2, 3, they've got some history on you, and then they sync with a partner, and they say, okay, your ID over there is ABC. Then you go and you clear your cookies. So for this well-behaved partner, you now have a new identifier with new history that they aren't associating it with your old one. But once they've cookie synced with a bad behaving partner, that partner has now sent them the same identifier, right? So this effectively, whether or not they're using it, they effectively are eliminating the no respawn rules, right? So once you're engaged in a lot of cookie syncing, it's very unlikely that you actually get rid of that identifier whenever you clear your cookies. Yeah.
So I have to run, but I got a comment or question. So I actually know a guy, I actually know two companies, and what they do is they sync the data. So one may have your first name, one may
Yep.
have your last name, one may have your phone number, one may have your email address.
Yeah, we're getting there.
Okay, so you know where I'm going. But what I'm not saying here is there anything that actually compromises besides like just tracking you? Is there anything that actually gets like your first name, PII? There
Yeah.
is?
Oh yeah.
Oh crap. Just,
Yeah. All right. Yeah. No. If you have to leave, then whenever we do the recording, or you can come to Thunder Plains.
What's that?
Or you can come to Thunder Plains. I'll be giving the talk again.
Thunder
At
Plains?
Thunder Plains. Yeah.
November 3rd, November 4th.
November 3rd, November 4th. So I'll be giving this talk again if you can't make the rest of this, but I'm sure we'll post it after Thunder Plains, right?
Yeah, it'll be posted after that. But
So-
you should definitely go to Oklahoma City,
Yep.
November 3rd and 4th.
Thank you.
But yes, we will get there. Okay, so cookie syncing basically creates massive cookie databases for trackers, right? Like they have a bunch of cookie identifiers for you in a bunch of different databases, and then now they have one massive database to track you across all of the different trackers. So let's talk about doing this without cookies. So cookies basically are known to be sort of a privacy and tracking issue. So there are tools like Privacy Badger and things like that that are basically meant to stop cookies from tracking you online, right? There's also Safari, just by default disables third-party cookies. So HTTP requests in Safari don't even send cookies to third parties at all. And so advertisers are basically looking for a way to keep tracking you without cookies. Also, cookies are notoriously horrible on mobile because every single instance of you browsing on a mobile device has a different cookie identifier and that kind of thing. So trackers are looking for another way to basically track you without cookies, and that's where device fingerprinting comes in. So EFF has a site called Panopticlick, which is a great demonstration of different device fingerprints. What a device fingerprint is things like this. What is your screen size and your color depth, right? So they find out what that is. They can just ask the browser for it. And then they add up sort of, okay, you have a canvas fingerprint, these are the plugins you have installed, and that kind of stuff. And if they get enough of those pieces of information, that's pretty unique to you as a web user, right? So there are passive fingerprints. So the easiest one is sort of the user agent that is always sent in your request. It says, I have a Mac, I'm on this version of OS X, I'm on this version of Firefox or whatever. Some of the stuff in here, like the languages that I accept, that can be identifying. And then I think there was one other, but I don't see it in there. So one massive abuse of passive fingerprinting was Verizon was doing HTTP header injection, so that if you were actually on the Verizon network, they would add this header called XUIDH to every single request that you would make. And that would go to their partners, it would go to other web servers, and they would regenerate it and respawn it even if you tried to get rid of it. So they would actually use it to respawn other cookies. So Turn.com was an advertising partner of Verizon's, and what you could essentially do is you would send this identifier as if it was Verizon. Turn.com would set an ID for you, and then you would go clear it out. And then if you came back and set the same, so this is just simulating Verizon and adding that header again, then Turn.com would actually respawn this previous one before. So they would use Verizon's header to respawn the previous identifier for you, previous cookie ID. This is actually all of the partners that were in the sort of cookie syncing ring that suffered from this respawning thing. So what happened was you would go to adadvisor.net and they would have a link over to adapt.tv. Adapt.tv had a link to AdNexus. AdNexus had a link to AdSymptotic. It just goes back and forth there until basically everybody has your identifier again. So even if some of these partners are trying to be nice and not keep your identifier for you, because Verizon was sticking a header in there and Turn.com was respawning it, everybody has it all again. Active fingerprints are fingerprints that actually have JavaScript executing in your browser. So an easy one is actually plugin enumeration. There's literally just a thing called navigator.plugins, like tell me all the plugins they have installed. And so there's a giant string of all the plugins you have installed, and it's whatever you use for your company's voice calls or whatever. That's actually being phased out. It's becoming something that instead of just enumerating all of the plugins, you would actually have to ask if the browser has this specific plugin installed, which is good, but there are also sort of enumeration, I guess you could call them attacks, basically just phishing attacks on plugins, or in this case it would be fonts, right? So font enumeration and font fingerprinting has been going on for a while. What happens is you set up some base fonts. These are just browser defaults, a certain size and string, and then an element you want to stick them in. And then you set the text content of that element to be a certain string, and then you're going to measure the width and the height of that element based on the fonts, the system default fonts that are there. So then what you do is you go through a font dictionary that you want to see if the user has these things installed. And you go and you reset that element to be that font, and then you remeasure the width and the height to see if they have changed. If they've changed, then the font actually changed, and the user has that font installed. If they didn't change, then it's still stuck on the default, and you know they don't have that font installed, right? So this is a way you can just essentially go through a whole dictionary of fonts to see if a user has them installed. Canvas fingerprint is a similar deal. The way Canvas works is that you can essentially just fill text and rectangles and stuff inside of a Canvas element. And so this is code that does that. Basically, depending on your screen size, your color depth, the graphics card you have installed, the fonts you have installed, like all these other kind of things that you might have installed, your Canvas image might look a little bit different to somebody else's. So this is the same exact code going through, I think, 15 different browsers, right? And they all render a little bit different. The trick here is actually this toData URL, or toData URI. So this actually creates, it says whatever's in the canvas, just create a base64 data URL of that, which ends up being a fingerprint. So each one of those things is going to be a little bit different for each person. So that's just a way to take Canvas, draw this thing, read what it actually has in it, and turn that into a fingerprint. You can do this with WebGL. I'm not smart enough to do this with WebGL. You can do it with WebGL. There are WebGL docs that do it. It's same concept, like depending on graphics cards, things will render differently, right? Audio context is another deal. So the way the audio API works, you create a bunch of nodes. In this case, you just set up an oscillator, like a constant tone of a certain hertz or whatever. You can set this gain value to 0, so this actually happens silently, so the user doesn't actually hear anything. And then you can basically sample it. So every, give me 32 samples of whatever the hertz was, and give me the, it's the bits, so you can actually take the float frequency data bins and then push that into like an array of them and then MD5 hash or whatever. So that ends up being a little bit different for devices depending on like the audio chipset you have or whatever. So in this case, you see the red one is like a sample, baseline Chrome on Android, something or other, and then the blue one is just another device that is a little bit different, right? WebRTC, if anyone's used Google Hangouts, Facebook Messenger, Firefox Hellos, use this. It's essentially a way to do Skype without having a plugin. But one of the things that WebRTC actually exposes is your local IP addresses. So when you ask for an RTC peer connection with WebRTC, you can, on this candidate, whenever the connection finds a potential candidate for doing the connection, it'll receive this object, and then if you basically like regex and you make a Horcrux, then you can do this nastiness, which will actually pull IP addresses out of that certain part of the string. So essentially what you have is you go somewhere and you can see, okay, your VPN, local IP address, all that kind of stuff. So you can make a fingerprint out of that, or you could just use it. This is the maybe creepiest one that I have not tested yet, but I'm dying to. So WebVR has, it's basically virtual reality, Oculus Rift, all that good stuff. So there's an API called WebVR that gives web developers access to this stuff. When you get VR displays from the navigator, they actually have, each VR display has a get eye parameters function, and you can tell it which eye parameter you want to look at. And so the way VR displays work is that they have sensors inside of them that look at your eyes and actually measure the interpupillary distance between the bridge of your nose and the pupil of your eye on each side. And they do that so that they can readjust the focal plane of the display that's inside the headset to match what you need. But the issue here is that when you ask for that measurement, the precision with which the API is written ends up being like 1/1000th of a millimeter, which is unique to every person on the planet. So it's essentially like a retinal scan. It's what's effectively a retinal scan. So you stick your head inside a VR headset, and someone's taking your retinal scan. So device fingerprints, essentially there's a lot of other stuff in here that talks about cookies. You can think of device fingerprints as just being cookies by another name. So anything that mentions cookies, you have cookies disabled, device fingerprints will do just as well. So how much time do we have? 7, 12, how long do we want to go? Another 15 minutes? 15? Okay. All right, we'll shoot through this. So cross-device matching. So trackers don't want to track your devices, they want to track you across your devices. So this is very much a problem that trackers are tackling right now, is how do I know that you are the person behind that watch, that phone, that tablet, that laptop, and you're all the same person, right? So one way to do it is probabilistic, what they call householding. So the way this works is essentially you've got all these different devices, they have different cookie identifiers. But what they can find is that, okay, well, there's this IP address that's hitting our stuff with a certain identifier from 9 a.m. to 6 p.m. on weekdays, and this phone that is, hitting it from a different IP address, and that's 9 a.m. to 6 p.m. But it's also, early mornings and weekends. It's coming from this other IP address, and then that IP address is also hitting us like, early mornings, evenings, and weekends, right? So, hey, you know what? We're 80% sure that this is probably their work computer, this is probably their cell phone, and this is probably their home computer, right? Now, if you want to get a little more specific about it, you could actually check the location data on these. So you could say, okay, well, this is this latitude, longitude, and that phone's being used from the same latitude, longitude, and those times, so probably same person. And then that phone moves here, and then this device is also here, right? So now we're, say, 95% sure. And then finally, if you want, you can just say, okay, well, what kind of browsing history do we have for this device? Tech news, UVA sports, Capitol Hill, Arsenal football, like the same categories, same activity is going on in all these things. Now we're 98% certain that this is the same person. And so you build up a device graph that basically says, this identifier is this identifier is this identifier is the same person on 3 different devices. Deterministic device matching, this is basically you're signed into somebody's service, and so you're signed into Twitter on all of your different devices. They just know, right? That one's super easy. So real quick, 1 billion people use Facebook on their phones, and 80% of the top apps are using Facebook logins. People are guessing that Google has 600 million to 1.2 billion people signed in across devices. So if you've ever looked at basically your Google, like you're signed into your Mac and your phone, right? So first-party deterministic matching, this is super easy. You're logged in as the same login and all these different things. I'm gonna, I think, skip. Yeah, so this I'm gonna bring back in a second. But there's also a way to do just email for first-party cross-device tracking. So let's say you purchase an item at a shopping site with a certain email address, and then they've sent you an email, like a receipt or something, and you click on that email in your phone. And they know that it was a one-time code, so like, oh, okay, cool, that phone is that desktop, right? And then you also reopen the email on some other device, and now they know, okay, well, that's also them, right? This one's a little complicated. Does anyone like machine learning? Okay, so I'll touch on it. I don't understand it. I cannot write this in JavaScript. So essentially, the trackers that do not have deterministic data are looking for a way to do this with much larger data sets. So they're not the Googles, the Facebooks, the Twitters. They're some other track you've never heard of. So what they do is they acquire a certain device activity data set. Like they go to Verizon and they say, I want this zip code and I want all the activity for this month or whatever, like everything that you've seen. That includes all this kind of data. Then they go and they acquire a smaller set, a truth set of deterministic matching data. So this is either someone's done it with the email trick or something like that. but they know that these devices for sure are the same person, right? You take that data set and you split it into two. You have a training set and you have a test set. You start to create a machine learning model that you point against this training set, and then you evaluate its results against the test set, right? You refine this model as you go, and then eventually when you've got it to a certain amount of accuracy, you point it at this big device activity data set, right? So then you can go find, okay, everybody in this zip code, I want to know who has which devices, right? So I got curious about where are they getting deterministic data. Google has a good privacy policy. They're not going to sell your cross-device data to people. Facebook has a pretty good policy. They're not going to sell something that identifies you. This brings up a point about trusted third parties. So I use Google, I use Facebook. Some of the big ones have really good privacy policies because they're under the microscope. If you trust them, you can use them. I have no qualms that Google is actually out to kill us all or anything. So if you trust them, but you should recognize that you're trusting a third party with basically all of your data, right? So this is a report that the EFF puts out about third parties that have a lot of our data and how good they are at protecting it. So go check it out. So I promised to get back to the email thing and to the third party thing. So what happens in a lot of the tracking sort of networks that are going on is they say that they do not share your personally identifiable information like your email address. What they will do is they will share like an MD5 hash of your email address because it's a one-way hash, and they say, okay, well you can't go backwards from that. So really this is just a random identifier for a person, not this person, right? So I think I might have my slides mixed up here. This one is a good one to talk about. Hold on to this for a second. Slides are in the wrong order. So PII leaking, this is what he was asking about, the way to actually get your PII. So what they found, I forget which research group did this, but there's a lot of contact us forms on the web. It's like, hey, contact us, give us your name, your email address so we can get back to you, and type us a little message. There, off it goes. A lot of those are implemented either by third parties directly, or the forms are implemented with HTTP GET, which includes all of that data in the URL. And a lot of the times they'll bounce you to a thank you page. And that thank you page has a bunch of trackers loaded. So what happens is your PII gets sent to like the web leads, wherever it is it's being sent in there. And then when you land on the thank you page, the referrer that's sent to that tracker includes your PII in the HTTP GET URL parameters. Yeah.
Is it important to know what PII stands for?
Oh, personally identifiable information.
Great.
Which
Thank
is kind of like a rough definition. Some people would say, that your geography is personally identifiable, right? Like your zip code. Some people call that PII, some people don't. It really depends. Like, I think there's someone did a thing where essentially, like, if you know somebody's birthday, the zip code, and their gender, you can find them. Like, that's pretty much all you need. You can find out who it is. So, but some people say, like, okay, so are those personally identifiable? That's your zip code. There's a lot of people in there. It depends on how much of it you have. So these are all of the websites that are accidentally or intentionally getting your personally identifiable information from contact forms. So you'll see a lot of the brands and names that you sort of recognize there. The add this is particularly interesting. So this is where I went down the rabbit hole and got my tinfoil hat on and went all conspiracy theory. So add this is a data partner of this company called LiveRamp. And LiveRamp, has anyone heard of LiveRamp? So LiveRamp is owned by a company called Axiom. What LiveRamp says that they do is that you have like customer relationship management software, like Sugar CRM or something. You have all your customers, email addresses and their data and all that kind of stuff. And they're like, hey, just upload that data to us, right? What could go wrong? So we will marry that with online cookies so that you can actually track your existing customers and you can see where they're going online and you can actually target your existing customers online, right? And so my conspiracy theory is that because they are partnered with AddThis and because AddThis is like, number 11 on this list of sites that's getting your PII, is that what they're actually doing, this is all of their other data partners they share data with, that LiveRamp does. And then their parent company, Axiom, makes this claim of having behavioral insight into 1.2 billion email addresses. So I think this is one of the keys. Like, if you want to be a conspiracy theorist with me, like, this is probably the person to point your newsletter at. So these are all of the companies that offer to do this. And I'm sure you've read all of their privacy policies. So hashed email for third-party tracking. Does hashing actually make data anonymous? So I don't have the code for this yet, but if you actually punch in, like if you go on a command line in Linux or OS X and you say MD5-S and then put in your social security number, you'll get an MD5 hash of that. You can actually put MD5 hashes into Google, and it will show you sites that have already cracked those. So essentially, if someone's looking at an MD5 hash of your PII and they throw it into Google, they may be able to just grab it right off of the first page of results. Yeah?
So you're saying they're building rainbow tables out of email pages?
Oh, there's gigantic rainbow tables. Yes. 190 gigabytes was one of the ones that I saw. Okay, so how much of this is going on? Web privacy census. If you go to the top 1,000 sites and click on a few links, you'll pick up 123,000 third-party cookies. The number of third-party hosts is going down. The number of cookies is going up. And the number of sites that have a Google tracking you went from 74 in 2012 to 92. So tracking is getting more prevalent. It's getting concentrated in fewer hands, and Google is the king. This is basically the top 10 trackers and the number of sites that they're on. So if the top 1,000 sites on the homepage, Google and DoubleClick are on 224, 214. You've got Quantserve. RLCDN.com, that's LiveRamp. This is the number, the percent of first parties that have Google Analytics, Gstatic, DoubleClick. Dark blue is if that is being used in a tracking context, or if it's being used in like CDN is light blue, right? So, okay, a third-party host is being included, but they're not tracking, they're just delivering you stuff. The number of trackers present on a site by category. So news, arts, sports are the worst offenders. If you don't want to be tracked, watch more porn online. Yeah. And the percent of first parties, so this is like the top 1,000 sites, 5% of them are using Canvas fingerprinting. And 2.5% are using Canvas font fingerprinting, and then 0.6% are using WebRTC fingerprinting. Some of the sites that are doing it, Dropbox.com, BBC.com, Groupon, Washington Post, some big ones there. Oh, and that's Canvas, Audio, Expedia, Hotels, Travelocity, WebRTC, a lot of the same ones. Expedia, Hotel, Travel people like to Audio and WebRTC fingerprint you for some reason. They probably went to the same meetup where people were like, oh, this is something I can do. Cookie respawning. This is mostly done in China and Russia now because you get sued for it in the US. Cookie syncing. This is the domain, like DoubleClick. They actually know 32 identifiers about you. This RLCDN, they know 17 identifiers. That's LiveRamp. This is a point that's basically, there's only 2 trackers that are present on 40% of the web, so they could see, in theory, 40% of what people do online. But if you factor in cookie syncing, then the number of trackers that can see 40% of what you do is actually 161 different trackers. And again, you've read all their privacy policies. So the good things we get from tracking, analytics, I love analytics. I have an analytics talk. I like Google Analytics. We get personalized services. Those are good. Relevant advertising. Advertising attribution is an interesting thing. I haven't had time to fill that one out yet. Preventing fraud, so fraud.net, essentially what they do is whenever you use your credit card, they will device fingerprint something that's using your credit card. And they might say, like, where's the location of it or whatever. And so they essentially track when you're using your credit card, but that means that whenever there's a charge that looks suspicious, it it flags in their system. Like, this is being used on a device we've never seen before, so you get the text message from your bank or whatever, like, is that really you, that kind of thing. So, okay, that's pretty good. Preventing criminal, so this is actually Axiom has this Sterling. What they do is criminal background checks. So they go and they find public data about people so that if you want to run a background check on somebody, you can do that. That's good. National security, so the NSA from Snowden, we know that they actually use double-click identifiers, Facebook machine identifiers, and that kind of stuff to actually follow bad people online. But all of these have a flip side. Knew we were going to do that, right? So over-personalized services, this is a book called The Filter Bubble. It's essentially, once you've used Google enough, it starts recommending you the same 10 websites that it recommends to you all the time. Like, your search results are always those same 10 websites. Facebook newsfeed, it knows everything about you and knows what you click on. It doesn't show you, other people's opinions or things like that. It basically, we're creating these massive filter bubbles for ourselves, right? Because people track us and they know exactly what we want to see, and they should show us what we want to see. Creepy advertising, I would say this is basically when Nike puts a commercial at the Super Bowl, it's not creepy at all because it's not personal at all. Then you start to get into like direct mail starts to feel creepy, and then like advertising on the web right now that tracks you is super creepy because you can tell it's just a machine watching you do things and getting it wrong most of the time. These are 98 options for targeting users on Facebook that advertisers can target. I think one is like people who've recently bought antidepressants or something. Committing fraud, so that fraud.net, right? This is a tool called FraudFox. So the hackers that are actually phishing for your credit card numbers, they will actually device fingerprint you while they're stealing your credit card number. And then they will save it into literally a thing called a .fox file. And then this tool, it runs a virtual machine to basically mimic your device so that they can go ahead and use your credit card on a device that looks like your does. This is Axiom's website. Since they do criminal background checks, they offer for, if you're a consumer and you're interested in what a criminal background check on you might turn up, come to this website and find out. And they have an invalid security certificate on this website. If you were to actually click through, one of the things they ask you for on that page is your name, your address, or your social security number. So, looking out for the little guys. All right, this is worth mentioning. Kind of political, but hey, you're in a privacy talk. So this is Prism slides from Snowden's release at the NSA. All of these companies, Microsoft, Google, Yahoo, Facebook, we're giving all of this data, your email, your videos, your photos, to the NSA. The problem with this sort of mass surveillance, surveilling all of this, is basically what you get if anyone's done any kind of like machine learning, data mining type stuff, right? If you're looking for signal inside of a giant database of everything, you need a well-defined profile. But the problem with trying to find terrorists in mass surveillance data is that there's no well-defined profile. Sometimes they use planes, sometimes they drive trucks across the beach in France. These events are so anomalous that if you look at a giant database of everything everybody does online, there's no well-defined profile, right? And then the cost of false positives should be low. So like, if a tracker wants to target an ad at you and they get it wrong, it's like, no, that's weird, and you don't click it, right? But if we base national security on this and you get it wrong, that's bad. And then you need massive numbers of true positives in order for data mining and machine learning to actually work. So this is the false positive paradox. Cory Doctorow's talked about this, but essentially, you'll hear about machine learning models, matching models, and data mining described in terms of accuracy. But the problem is that the number of true negatives in these equations for measuring accuracy will always dwarf the number of true positives, right? So you're looking for 5 terrorists in 100 million people, right? There's always going to be 980 whatever that are true negatives, and you found them. Good job. You're 99.99999% accurate, but that means nothing, right? Like, Great, you found 99.999% of the innocent people well. Good job. So, and it's basically when you watch everything, you don't see anything. So these are some stats on that. Let's get through because we're running out of time. So why aren't we doing anything? I think everyone kind of knows this stuff has been going on, but it's like, oh, well, it's just the price you pay for living online, right? But polls are basically showing that consumers are concerned, but people keep releasing data about themselves. And in America, we have this nose and choice philosophy when it comes to privacy. Basically like, oh yeah, we've got a privacy policy, go read it before you use our stuff, right? Well, I just showed you there's 123,000 third-party cookies on the top 1,000 websites. Have you read their privacy policies? No, we don't do that. This is Oracle's. It's particularly bad because it says other information could be demographic information, could be geolocation, and basically we can do whatever we want with that data. So what's happening is that Americans are actually resigned that this is just the way things have to be, right? So 84% of people say they want to have control over their data, but then 65% say, I just basically accept that I have little control. So here's how you can have control. So if you suffer through all the code and all of my rambling about machine learning that I don't really understand, here's the cake at the end. So incognito mode in Chrome is a joke. And they say it's a joke when you open incognito mode. Incognito mode is good at hiding last year's porn from next year's porn. Like that's all it does. Essentially, it's hiding your own history from yourself. But you are yourself. You know what you went to. So here's the Firefox plug. Firefox has private browsing mode. And in private browsing mode, we actually have tracking protection. So we actually block all third-party trackers from tracking you when you're in private browsing mode in Firefox. We have Firefox for Android that also has tracking protection built in. So if you have an Android phone and you didn't know that Firefox is on Android, it is, and it has good privacy features. We have an app called Focus for iPhones. So iOS 9 released a content blocking API, and so we made an app called Focus for iPhones that is essentially a tracking protection for Safari on iPhone. So go get that if you have an iPhone. Another thing you should do is use HTTPS everywhere. This is essentially, it will make sure that you always go to HTTPS sites whenever possible. That prevents a lot of the eavesdropping sort of vulnerabilities. And this is an add-on available for all major browsers. Switch to DuckDuckGo. I've been using DuckDuckGo for 2 or 3 years now, and I only have to go back to Google to search something maybe once every week or so. It's really good. They don't track you. They put a lot of energy into making sure you're not in a filter bubble when you're searching for stuff. Credo Mobile. If you use Verizon, Credo is actually like a secondary seller of Verizon services, and they do an excellent job sort of doing privacy where Verizon does not. Tor network. If you really have your tinfoil hat on now, you can run Tor or run an exif node. Like, hey, that'd be cool. Run a Tor node. It's essentially a browser that is anonymous. Just hops your traffic around the globe before it hits its final server. Encrypt your hard drives. This is easy on all platforms now. If you're a power user and you want to start looking at some of this stuff, Wireshark is a great tool to run. You can monitor what's going on in your network. Little Snitch is for Mac. It has a much nicer UI than Wireshark, and you can actually capture logs that can be viewed in Wireshark if you want to. So I've been using Little Snitch a lot. Charles is a web debugging proxy. I like this one because you can run this on your machine, and then you can configure your phone to actually use your machine as a proxy for its Wi-Fi. And I've found like unexpected network requests going from my phone at random times to my machine. If you're a web developer, HTTPS all the things, Let's Encrypt is awesome. If you haven't looked into that, definitely get it. There's no reason not to encrypt all of your traffic now. Use secure cookies. So if you are using cookies, make sure they're HTTP only and make sure they're secure only. Then HSTS, go ahead and use it, even though there is that vulnerability. This is a lot better than having people accidentally get bounced to the unencrypted version of your site. Preventing account enumeration. So this was AshleyMadison.com. You remember what that one was? So even before they had their data breach that no one felt sorry for because stupid cheaters, they had this element on their sort of forgot password page, and they did sort of the right thing, where they gave you the same message. So basically, account enumeration is you go to a site and you say, I forgot my password. They say, okay, what's your email? And you punch in an email address, any email address, right? And if the page says like, oh, we don't have that in our system, like, oh, okay, they don't have an account there. Or if it says, we do have that, like we just sent you a verification email, you're like, okay, I know that that person has an account there, right? So you should always show the same message, which they sort of kind of did, but then they took away these two elements on the page if the email existed. So like, I'm not a physicist, but those are two different things. So it's like, okay, nice try. Don't leak PII, StrawberryNet.com, worst thing I've ever heard of. They basically had a quick checkout. You could give them your email address, and they would just put the name and the address and the phone number of that email address on there, no matter who the heck you were. Like, you weren't signed in or anything. You just put an email address and get some PII. Apply to Mozilla, we're hiring. As a citizen, consumer, advocate, the subreddit on privacy is actually quite good. If you read Reddit, add the privacy subreddit. It's pretty cool. There are some tinfoil hats in there, and they're lots of fun. Electronic Frontier Foundation makes a lot of good stuff. Check them out, donate to them, get cool swag. And then the last point is essentially, I think before I started looking into this stuff, I, maybe like a lot of us or Americans, sort of thought that privacy was that thing that privacy zealots worry about, or people who have something to hide worry about, or you have to have some kind of reason, right, to be wanting privacy, right? Like people that run Tor networks or whatever, like, you people are crazy. Like, I've got nothing to hide. There's no reason to do it. After doing this kind of research, I am convinced of the total opposite. Everyone should just default to privacy, and it should be the exception. We should feel weird about getting tracked and being okay with it, right? There's no reason, like you have blinds on your house, and I close my blinds every night because it feels weird to have outside, like people out walking around at night just looking in the house what I'm doing, right? That feels weird. That should feel weird. Privacy is a thing that we all like, and I'm not doing anything wrong in my house, but it's not wrong to have blinds there, right? You have locks on your doors, you have blinds on your windows. That's not weird. The weird thing is supposed to be people tracking you online in order to sell you things or manipulate you. We call them sociopaths, except online we call them trackers. We're just like okay with that, right? So I guess that's my closing point is get some of the privacy tools, use some of the privacy tools, like privacy, it's not weird. And that's it. Woo! Questions? Yeah?
Do you have any examples of quote manipulation being used when being able to track?
Yeah, some of the ones that I've heard about is actually, it is, I think it was, I hate to pick on for-profit universities because ITD Tech already blew up. But I'll try and pick on them. So essentially there was basically a case where some university or some foundation or something that was funding scholarships, making scholarships available to people, were essentially only offering it to iPhone users because they knew that they already had money and could essentially like get into better schools or more likely to get in better schools. So they're essentially just manipulating people's access to education based on whether you have an iPhone or an Android phone. And there's all kinds of like weird, targeted advertising stuff that ends up manipulating people's like access to information or access to other things that you can get online, right? So it's just weird. That was one of the ones, and there were a few others, but yeah, that was the one that I was like, holy crap! Like people maybe are not getting an opportunity to go to university because of the device that they own, or because they don't browse the right websites.
So perhaps your socioeconomic standing affects the prices that you see.
Oh, very much so. Yeah. No, there's definitely been studies that have shown that advertisements and promotions show different prices based on what kind of device you have.
Thank you.
So is there still any value at all to clearing of cache, reading of cookies, anything like that, or is that basically if you happen to have gotten tracked at some point, then basically the data is probably just hopping around waiting for you to kind of touch base with somebody else again. And then it'll link them all up again and redistribute all the data, et cetera, et cetera.
Yeah, having a bunch of my data out there, I kind of know that it's pretty much there for the grabs, except with the new data. Like, 6 months or so ago, I started basically getting back my own privacy. And so since in those last 6 months, I've sort of probably disappeared off of a lot of radars. The historical data is still out there, and probably people can still use it and infer a lot about me, but like from here on, I'm going to stick with just keeping my privacy, right?
So I mean, you listed some of those ideas for stuff that happens to the user. You didn't happen to list deleting cache and cookies and stuff.
That stuff all helps. It can help and get around some of that stuff.
Because the privacy mode in Firefox does some of that automatically.
Yeah, it does. And what's funny is, so Tor itself is actually a fork of Firefox that actually has a bunch of stuff like that built into it. So every time you quit Tor, it dumps everything. Like every time you open Tor again, it kind of restarts everything. That's one of its features, right? And whenever you open it, I think like it basically makes your screen size, the window screen size, just a little bit different every time you open it, right? So that you're not fingerprinted by screen size. So it tries to do a bunch of these kinds of tricks sort of built into Tor, right? So the Tor browser is like sort of automating a lot of those like little things you can try to do. I personally don't do all those little things anymore. I feel pretty good about, like, I use the tools that I showed you, like with the exception of Tor. But I use, tracking protection, I use HTTPS everywhere and that kind of stuff, and I feel like that's probably enough. But yeah, I would say Tor is sort of the tool that does a lot more of those things. I think you can configure the Tor browser to not use the Tor network. So I think like if you don't want to bounce around the Tor network, but you just want to use the Tor browser itself, you can do that. So, more questions? Yeah.
How often do you browse without JavaScript?
Not very often. And it is probably the next thing that I will try is to do something like NoScript. I hear that NoScript is kind of a pain to configure at first, but then so was Little Snitch. And so when I did Little Snitch, it was like sending all kinds of alarm bells off at first. But then once you get past those, like for the most part, you now know, okay, this is the networks that I'm actually getting connected to. So I probably NoScript will be my next thing if I feel like, the stuff that I have right now isn't giving me as much privacy as I want. But I think it's a really good idea. A lot of people do NoScript. More questions? All right. Thank you very much.